Okay, everyone, so we're going ahead to Unit 13, Lesson 2 now. 3 of these belong to the group, the other does not. Which one does not belong? Let me see. They all live in water. They're all kind of edible. Be very careful of the fugu, also known as a pufferfish. Okay, very dangerous to eat, only if it's prepared correctly. So let me see. I wonder the group. Oh, so we have a fish, a fish, a fish, and a shrimp. That's what we call population parameters. The parameters. What is a fish? A limbless, cold-blooded vertebrate animal with gills and fins living wholly in water, totally in water. Okay, that's the definition of a fish. So that's the population parameters for a fish. We're doing Common Core Algebra 2, non-Regents version. If you don't understand what I'm saying, you can always scan that QR code and listen to the genius who wrote these worksheets and listen to what he said. Okay. When we conduct a study, the complete set of all subjects that share a common characteristic in that study is known as the population, so the population of fish. All populations have a natural or inter-individual variability, between individual variability. Most of the time, the entire population is not measured. That can be difficult. But a sample is taken to infer characteristics of the population. Still, all populations in theory have population parameters that describe the whole population. The ones that we're going to be dealing with are the mean, the standard deviation, and the interquartile range. There's several different ways to get those. 18 students in Mr. Wheeler's advanced calculus class took a quiz, and the following results in ascending order. You always have to place them in ascending order. If we're going to do it on paper. If we're going to do it on paper. Use your calculator to determine the mean, the median, and the quartiles for this data set. I'm going to grab my calculator. Okay, we can do the mean, we can do the median, we can do the interquartile range all individually. Let's see if we can do them all together at the same time. So what we do is you hit the stat key and then edit. You enter all the data. And how do I know I've entered all the data? When you're at the last spot, it'll say 19. Right there on the bottom on the empty spot, it says it's the 19th spot. There are 18 numbers, so we know we already entered in 18 of them. On top of the last one entered, it says 18. So we entered all the numbers. So we hit stat, we hit edit, then we hit stat again, go over to calculate, one variable statistics. Since we only entered in one list, we have to choose one variable statistics, hit enter 3 times to calculate, and there we have it. The first one, X bar, is 83.7. Now we're not just writing that down for the fun of it. That means the mean. The median, I had to hit down arrow once, and it's 84.5. And the quartiles, the first quarter, the second quarter, the third quarter, and the fourth quarter. Quarter 1 right there says 75. The second quarter is the same as the median, 84.5. The third quarter is 93. And the fourth quarter is the max, which says 100. I hope your volume was on, because I said a lot. Let's make a simple box and whisker plot. We have to go from 56 to 100. I'm going to count by fives. 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. Now, the minimum was 56, so that's a little bit above here, and the first quarter was 75. You draw a vertical line above the 75. The second quarter was 84.5. Draw another vertical line around there. The third quarter was 93. There is your box. The maximum was 100. There are your whiskers. Always draw to scale. Always draw your number line to scale. What's the interquartile range? Well, that's very simple. It's the box. Q3 minus Q1. 93 minus 75. That's 18. What percent of data should lie between there? Let me see. These are called quartiles for a reason. Each quartile should be 25%. So the interquartile range is 50%. Is it true for this data? Let's take a look. Okay, so I took a look at these numbers, and Q1 is 75, so I put a line through 75. Q3 is 93, I put a line through 93. And then the Q2 is 84.5 right in between those. So here, we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So each quarter has exactly the same amount of numbers, but what? Oh, this isn't in quarter 1 or quarter 2. So how many are in here? There are 8 in here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 out of 18. Is that half? No. 8 out of 18 does not equal half. How can we have 9 out of 18 in the middle? And then there'd be less than, either more than that on the left, less than that on the left. You know, it's very strange. Since there's an even number of numbers, we can't divide it like that. That's not quite right. I mean, we have an even number of numbers, like with 100, so it'd be 50 and 25 and 25. That's really nice. But the fact that when we divide it in half, we have an odd number, 9 on the left, 9 on the right. You know, so yeah, the middle divides into 2 equal parts, but you can't divide 9 in half. It's 4 and a half and 4 and a half, so that kind of straddles. The 93 straddles, the 75 straddles to the left and right. I get off topic a little bit. So what's the population standard deviation for this set of data to the nearest tenth? Really? Population standard deviation. So we go back to the class and we're saying, is this everyone or is this just a sample of it? Since this is everyone, we're not going to use the sample. We're going to use this number right here, 11.7. Sample, 12.04, 12.05. Everyone, the whole population, 11.7. Calculators are a wonderful thing. I really hope your volume was on. What percent of the scores were within one standard deviation of the mean? What's the mean? The mean was 83.7. The standard deviation was 11.7. This is what we do. Okay, so this is what we do. We take the mean plus the standard deviation and the mean minus the standard deviation. We go up here to find the mean. The mean was 83.7 plus 11.7 equals 85.4. And then the mean minus the standard deviation is 83.7 minus 11.7, which equals 72. So now, how many are within one standard deviation? All the scores from 85.4 to 72. Up to the scores. '72 to 85.4. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 scores. Notice that the mean and the median are close to each other. I was noticing something, and thank you very much for shouting and saying, hey, Mr. Bryce, this is the wrong answer. 95.4. Extend it more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 scores. Okay. What does that look like? This is what a standard deviation curve looks like, and you'll notice, I want you to notice, that that's one deviation from the norm, and from 0 to 1 is one deviation from the norm. So we have to have the minus and the plus. When we add up these percentages, it adds up to a total of 68.2%. So now I'm going to do 13 divided by 18, and we get 72%, or percent to the nearest percent. 72, sorry, I'm writing with a mouse right now, 72%, 13 out of 18. So that's good. Should be right around 68, and it is. This says within 2 standard deviations. So if I add another 11.7 onto this and subtract another 11.7 from 72, this is what I get, over 100 and 60.3. So you look at this, you know, like over 100 and 63. Okay, so that's everything. That's 17 out of 18 scores, which is 94.4%. Going back to the curve, if we want to go out 2 standard deviations, again, it's everything but this little tiny bit. Boink, boink, boink. Boink, boink, boink. 3.4, 4.4, 4.6%. So it's extremely close. It checks with the curve, with the standard curve. Okay, that's a lot to digest. We're right about 16 minutes now. So we're going to stop for now. And on the first page of homework, ask me about number one. Okay, really think about it. You have to remember back into ninth grade, the first Algebra 1, okay, and really think about that. But you can do 2, 3, 4, and 5. So that's tonight's homework. Okay, I'll catch you later. This is Mr. Price, signing out.